So our speaker is PG Tan. She is from ViTrox Corporation. She is currently the product marketing manager. PG has been in the SMT and the inspection solution industry for over 10 years. Her role now at ViTrox is responsible for the success of new products and solutions. In today, her presentation, he will introduce the technology and solutions that ViTrox develop on the AI that can support the manufacturing with improve the inspection capability, accuracy, efficiency. So let's go ahead and welcome PG to give her sharing. PG, I would like to pass to you. Okay.
Thank you, Helly. And hello, everyone. So I'm PG, as introduced by Helly a couple of moments ago. I hope you can see my screen right now.
Yes.
Okay. So first of all, I would like to say thanks for your interest in this webinar. And I'm going to share about the AI-powered solutions towards the smart manufacturing that we actually developed and deployed, I would say, these recent years. And of course, this why are we talking about the AI? It's really a very hot piece of cake nowadays, right? Okay, so I will start with the outline or agenda. Of course, I'll go through the introduction, what is the topic about, and then we'll touch about the problem statements and challenges. Typically, that will be the human dependent, human error, time consuming, all these matters, and followed by the AI-powered solutions that I'll share with you, a few modeling and also the milestone that we have gone through. And also real case study and implementation with the results as well. And lastly, the findings and conclusions. Of course, last but not least, the Q&A session where it will happen at the end of the session. Okay. Okay. So the first terms that I'm going to share with you, smart manufacturing. I think a lot of us hear this nowadays, and it has been there for many years. Maybe I think the first time I've heard about that, maybe 6 or 7 years ago at least. A lot of people are doing a lot of different methods or approach to achieve the smart manufacturing operation. So the ultimate goal is actually all about cost savings and also how you can achieve better yield throughout the smart manufacturing operation, and also quality and throughput. Okay, there's a lot of things that we want to achieve through the smart manufacturing. All right. So I'll be going through with you the SMT line, what it is. So in the beginning, we have this illustration actually starts from the solder paste printing. This is very common. So the first station is usually the solder paste, solder paste printing. Then go through all the inspection system with floor oven and so on until in-circuit test for this case. And those that are highlighted in the red dotted box, those are the filtering gate of each of the each of the process, or in other words, those are the inspection system. And of course, ViTrox provides offers all the solutions for each of the inspections. Okay, and I have a question to all of you. Do you know how many human or workforce are required to support a manufacturing line? I think there are a lot of us that have answers that there's a lot, but anyone with the numbers, I don't think so, because it's always a lot, but countless. Okay, to me, sometimes it's countless. But eventually each of the inspection system will require at least one operator at this stage. I'll say from many years ago until now, we still rely a lot on the human or the operator to do the job at each of the inspection system. So what they usually do, manage the bot handling and also to perform double verification towards whatever inspection results from the each of the stations, right? But in fact, there's a lot more operators in the manufacturing line that we do not know what is the actual number. So it could be varies also depending on the line's configuration. Okay, so before we get started even more, before we go further, I would like to show you a very quick video, this to illustrate what I'm going to share in the latest part. So feel free to enjoy your video. Yes.
Yeah, PT, we cannot hear.
Oh.
Sorry, you need to check it. Can
Oh,
you
don't worry
share
about that.
again? Yeah.
What about? Is it okay now?
Yeah, I heard a sound, but seems you pause. Is the video running?
Yeah. The video is running.
On my screen, it seems frozen. I don't know if for the others.
I see a black screen.
Oh, really?
Yeah, maybe just try again, share again. Yeah.
Okay, sorry about the technical error. I will try it once again. So you'll be able to see the screen right now?
Yes. Here we go.
Okay.
AI VVTS is the AI verification tool for automated and intelligent inspection data justifications. Before utilize AI, operators will manually verify NG calls from AOI. We can configure AI to automate judgment on the true defects and remain the real NG calls from AOI for operators' further action. With more than 90% AI coverage, you can automate the verification of inspection data. With AI-powered solution, we address the challenges of the production process to support customer requirements to further achieve smart manufacturing.
All right. So I hope you enjoyed the video and have a very quick overview on what I'm going to share or the understanding of the topics in details. So I will go through a little bit more details with the flow that we have. And of course, now I will be focusing on the AOI systems instead of any other equipment. And typically what we are used to, which is a very conventional method. So AOI perform the inspection, then there will be NG data and the images and also the results that are sent to the review station. And at that point, there will be operators to perform second buyoff after each of the inspections. This is something that what happen nowadays. So you can see that the human being has to hold probably a scope to do that job because some of the component is really small. But you can imagine that if the ng calls is a lot, so definitely he or she this is definitely a burden for he or she to do that job because it will be very time consuming, right? And it could be incurring errors. So as a conclusion, using the human operation, like I mentioned just now, time consuming or the speed is very slow, and also tendency of error is very high, and also wastage of the cost or money or more monies have to be spent in order to correct some of the, for instance, defects that escapes to the back end, and to the rework cost is increased because of all these mistakes that done in the front end, right? So this would definitely results in an unhappy boss, right? Next, I'm going into the problem statement and challenges. So in this case, I will start with comparing a judgment of two different operators. There will be a person A or B, A and B. There's a lot of charts here, but don't worry about all those figures. So we'll focus on the green, the yellow and the red regions. Okay, yellow and the red regions. The green one is something that is already in good shape, where they are good or accurate, so we don't have to focus on that too much. But then the yellow one is the false call rate, where it is the tendency of the operator to overkill the judgment results. So if we are comparing the yellow region or the false call rate, we can see from this comparison, A has the tendency of overkilling by 24.49%, which is very high. If comparing to operator B, A is not that competent, or he or she may be too careful. Right? While if the other one that is more alarming is the red region, which is the escape rate. And in fact, there's no escape is allowed all the time, anytime, right? If you're doing even letting go one defect, this is very serious. It could create a lot of issues later on. So the escape rates for operator A is as high as almost 40%, while operator B looks like is performing better, but he still has the tendency of letting go the true defects, 2.2%, right? So in this case, we can make a few assumptions that operator A and the comparison between them. So I will say that operator A is less competent, or he or she is not in a good shape on that particular day, or he may be emotional disturbed. So whatever reason, there's a lot of factors that will impact or affect the judgment of one person, right? So this is something that it sounds may not be that we cannot imagine if we don't really look into that, but this is a reality that happened. Okay. Talking about the problem statement and challenges. So as I mentioned just now, there are three main factors or the problems that we see over the years, over the days. The first is always the high human dependency method, where A to E, all these A to E are what we see is very depending on individual, or even sometimes A can be better, but it's not necessary every day and all the time, right? Then the product quality and throughput, and also the operation expenses. 2 and 3, the factors are from number 1, so they are actually interlinked, and one contribute to the problems of the quality, throughput, and expenses, very obviously, right? Okay, so we know that we have to do something to overcome the challenges, but how we can achieve labor reduction or reducing the dependency on human, or how we can achieve tools that we can develop a tools that can achieve an intelligence comparable to a human being. And third, how we can achieve cost reduction. And of course, fourth, better yield, or in overall, we get more throughput and also higher quality. Right? Okay, so we're going to talk about the solutions for this particular problem statement that we found. And I will start with sharing terms that we oftenly talk about. And I think you saw these terms in the video that I played just now. So basically, the ViTrox verification tool solution is the name of the repair tools, and it integrates with the AI. So I will talk about that a lot in the coming pages with the case study and also why. All right, so we'll come to the new flow after we have the AI. Then you can see that the main difference is that we integrate the AI inferencer into the review station. So in this case, there will be a reduction on the operator effort in doing the job, because the AI will approximately covers 70 to 90% of the data and automatically complete the buyoff process. So in this case, I would say 10 to 30% now, we still have to do it manually. So it very depending on the condition. 10% to 30% could be something that the AI is still not able to cover at the moment, or there are a lot of NG or true defects that potentially we will leave it configured to let the operators to manually do the judgment or further action, because a lot of times we need to dispose, or we need to send the bot to the rework, repair, and so on. Right? Okay, this is a slide that I actually want to share some stories, and it's about the very classical use model of the AI modeling in the market. And also, we have gone through this at the very early stage of the development. Back in, I think, at least 5 to 6 years ago. So the very classical model is that we will require very huge amount of training data to do the AI training, and also we have to have very accurate data. For instance, if it is a cat, then we have to collect thousands or even millions of images of cats. So it's really a lot. Then, if we have two different features to train, which is creatures or features, that dog and cat. So in this case, we get to collect a lot of information for this particular model that we want, right? And after the training is completed, whenever we have another input, which is a dog or a cat, if it's gone through the AI classifier, the very classic mode, the AI will be able to identify, okay, this is a dog or this is a cat, meaning they will be able to identify and classify the input correctly according to the training data that we collected very early stage, right? While if we have another input, which is a non-cat or a non-dog images, for instance, a horse or a tree, when it goes through the AI classifier, there will be some confusion to the AI classifier that it may not be able to identify them correctly, yet it does not know that what they are, right? So they will still, the AI will still classify it as possible it is a dog, or possibly it is a cat, but in fact, it is not right. They are not the correct output. Right? So this is some of the limitations that we typically know on the classical model. So we start with that path, and then we found that there's a lot of issue, and we have to keep on do a lot of training to fulfill that particular conditions when there is a new pattern. So at the end, we decided to move to another method, which is a template based. So similarly, we do some training at the beginning, right? We have some fundamentals already, but then we utilize the template-based information to do the real-time AI classification. So in this case, we don't have to have a lot of data to collect at the beginning of the stage because we already have that in our library. Then we will also we will rely on the input, the real-time input, which is the dog or a cat template in this case. So immediately the AI will be able to classify the output correctly as a dog or a cat. And in the third condition or the third example or the fourth condition where there is a different pattern that exists, if we go through the AI models, we are able to identify them. Okay, this is not what I have learned earlier. This is totally different things from what I have learned earlier. So the output will be as something that is called not covered or not in the coverage, in the other words, right? So it will not create a wrong output or wrong results. This is a very typical comparison that applies in the actual use model for our case because we are doing inspection, right? So in the classical use model, you can see that each of the classifier is required for each categories of defects. This is what we usually see. So we might have to have a lot of different models, but it only applicable to each individual categories of defects. Because of that, so we decided to have the assemble pipeline where we integrate all the different AI modeling, so we can cover all the defects, all the defect types that we would possibly see in the AOI, right? Okay, typically the differences, of course, there is always pro and cons in different different use models. I'll say that the left one, classic models, it could be easy to train and implement. No hyperparameters or fine-tuning is required. But at the same time, what is the most critical disadvantage is that it requires constantly retrain to cover the untrained scenario, like what I just shared just now, the horse and the tree that is not being trained earlier. We have to keep on training the AI. So this will actually requires a very long and continuous effort. While for the current model that we selected, yeah, it is quite complex because actually we also have to go through a lot of different pipeline training and so on. But at the same time, we found that it is more robust and it is better to ensemble with the different classifiers and low false calls and escapes, and it can be more flexible to configure. All right, this is some of the images from the AOI inspection, which the AI is able to classify into different defect types, I'll say. On the left is, of course, the good images, and then on the second column is the missing component. Offset or skew, this is more on the alignment. And the last one is the OCV or polarity matters. All right, so now I will be going into the case study. This is a real case study that conducted in one of our clients. the results is, I think, in 2020, we started the project in 2021 throughout 2022. Okay. So very preliminary information, 3 different charting. I want you to focus on the 2 highlighted boxes, which is the AI impact and also AI coverage. So from time to time, we do see the results actually improve towards towards the different time, because at the beginning we see the impact of 47%, then slowly it increased until it's like 70%, and also the coverage as well. So we managed to increase the coverage or improve the coverage until about 97%, 98%, I would say. Okay, this is a little bit more details from the previous slides. So if we start the data analysis from this is around the August or September timeframe, and then the end is around May or June 2022. So if we focus on the blue line, which is the AI coverage, we can see the trend. The lowest point is approximately 30%, and it is an incremental trend going up, and the highest is approximately at 80%. Okay, so that is the coverage increment or the improvement that we observe. Next will be the yellow line and the green line. You can see that the false calls actually also slightly, I would say quite consistent, but at the end it is actually slightly increment. But don't forget, the actual data that we are referring to is the green dotted line. Why do I say so? The yellow line is the data before relabel, which is around 25 to 45%. And after relabel, it is approximately 15 to 20%. And I think you will ask, what is relabel? It is an action to verify the post data by the AI and operator, meaning that we are going to do one round of filtering analysis to make sure that the results from the AI and also operator, whether they are correctly classified into the real defects or they are really the false calls. So at the end, we managed to conclude that from the discrepancy before and after relabel, okay, we observe the worst case of the operator error is as high as 30%, which is 15, and the difference between the 50% and the 45%, the worst case is up to 30% of operator error. And the false call rate for AI currently is approximately at 15 to 20%. Okay. Don't worry about this table. There's a lot of information, but what I want to bring out here is that you can see from the left column where my cursor is right now, from different months, we actually implemented a new AI model from time to time, because we are keeping on developing or improving the AI use model, right? So each of the row of the data representing the corresponding time frame. So in conclusion, AI escape is very low. It's all below 1% for sure, and the highest is only about 0.04%. Accuracy wise, it is as high as approximately 70%, with the false call rate as high as approximately 44.57%, which is very high, right? This is even worse than what I've shown you just now. But bear in mind that this is the data that before the relabel. So we did the relabel action to verify the discrepancy, and we found out that the operator error is approximately at around 20%. So this supports the statement that I've shared just now, 10 to 30% on the maximum. So, but the figure shows that is around there, 20 or sometimes 20 over percent. Okay. AI impact is improving over the time from 25% to 51%. You might be asking, what is AI impact, right? In fact, the formula is that AI impact is the accuracy times coverage, or in other words, if the AI covers the defects or the type of the components and how accurate it is, it means if that whole thing works, then that creates the impact. So we call it the AI impact. And our typical target is greater than 50%. So why is it 50%? In fact, this 50% at least representing half of the workload can be reduced. It means, or in other words, it is possibly to reduce 2 operators to 1. That is another terms of understanding it. All right, this is the AI analysis on the escapes rate. And I have created 2, this is for 2 different timeline or month. On the left, it is the data from March to April 2022. The escapes rate is around 0.138%, while in the April to May, 0.0221%, which we see a drop of approximately 0.1, almost 0.12%. Okay, but in all, I would say that the escapes rate is still within our target, which is 1%. Remember, if we compare to the operator escapes that I shared in the previous slides, the best operator on the right one, he still has the 2% of the escape rate. So this 1% is something that we can benchmark. Is much better than an operator. Okay, this is a little bit more about the escapee analysis that we usually perform after each this is during the reporting stage. So we are utilizing the labeling charts function to do the analysis. Of course, based on the images or sample right here, we can see that some of the defects are marginal defects, but some are obvious. For instance, this SOIC is there's a defects on the lid. It's a solder breach. Okay, so in this case, it is definitely a missing. This is definitely something that we need to further act on. So our action item is always to continue the development or continue to perform the AI training and also fine-tuning the AI modeling model, okay, the accuracy and so on. All right, the next one, this is the defects that classified by the AI. So I think obviously a lot of these are the true defects from the AOI that they are obviously true defects, and AI is able to do all the job correctly. Okay. Next is the false calls. So if you talk about the false call from the AI, we also will do a lot of analysis why the AI will overkill those results. But in fact, there's a lot of time that we also observe some certain, I'll say, interference from the actual on the actual images. For instance, those that are highlighted over here, we can see that actually there's some disturbance, I'll say, disturbance from probably the neighboring components that having the defects. So all this is classified under the false calls because AI couldn't classify them correctly due to all this disturbance. So, but all the other models that we see, those are overkilling. Definitely, we will continue to perform the AI accuracy improvement. a little bit more about the AI false calls. So I take a few examples and I classify into the left and the right side just to differentiate them in the terms of actual defects or if they are actually the overkilling. So on the left, all these images are they are okay condition. There's nothing wrong. Those are not defects, but AI is overkilling. So what we're gonna do with this, like I mentioned, it requires some retraining. While on the right one, for instance, these two connectors, you can see some differences between them because one is with the cap and one is without. I think this is very common in the production line because a lot of time the cap is sometimes not being removed when it is going through the AOI inspection. So we have to retrain it we have to collect the recollect some of the image real time to have the correct template in order to proceed with the AI inspection. Okay. Well, for the third and the fourth, obviously the third one is actual defects because you can see that this is a wrong component, I will call it, because the component does not match to the pad, right? So AI say that this is a false call. No, it is actually a true defect. This is a true defect, but the operator pass it, and then AI says this is a true defect. So it becomes the false call. Okay. So, and the last one, inspection window is wrong. In fact, this is some algorithm settings issue, but AI is still able to make the correct judgment, right? But it's actually already overkill it in the case that because of the algorithm settings. Okay. In terms of the success story, so this is, I would say, the conclusion from the previous case study. We got a lot of the inspection data, and at the final one, we are achieving approximately 80% of the coverage with approximately 52% of impact. And this is happening in the real client's production environment. They implemented the AI into more than 30 of their AOIs. So we see the approximately 52% of reduction in the human workload because of the impact. Cycle time improvement of approximately 80% because AI coverage, right? And human escapes is greatly reduced to less than 0.05, which is within our target for sure. Okay, this slides actually shows a lot of data from different timeline, but don't have to worry. I know there's a lot of figures to digest, but what is the key important takeaway in this particular slides is that the AI impact started from June 2021 is approximately at 26% only, and at the end of the projects or implementation, it is achieving approximately up to 71%. So you can see how much the AI is impacting with the good benefits that bring to this particular implementation. And of course, that is based on one of the client's success stories. And eventually we have a lot of different clients that run the solutions. And you see this here, there are actually 6 different data from the 6 different clients. But of course, there are actually more, but I will just select 6 of these to share with you all. And we observe the coverage nowadays. This is the most recent data. So the most recent data shows that the coverage is already at the 90% range, or even up to 100% for some cases. And the impact 45, this is the minimum, 48% until 78%, which is I would consider very quite high and very high. Okay. All right, I almost come to the conclusion part. So from that particular case study that I have shared, we observed the improvement over the 10 months of data collection, right? Of course, the improvement in the coverage, accuracy, and also escapee rates. And then we will conclude that the results and the impact is that we observed at least 50% of the labor reduction because of the impact. So we, like I mentioned just now, 50% here could be referring to 2 operators could be reduced to 1. But of course, slowly we aim to do better, where it could be humanless at all in the future, right? Buyoff time greater than 80% reduction. This is referring to how good the AI to cover all the defects results from the AI. Human error greater than 1000%. This is actually, in other terms, 10 times better, meaning that the escapes rate actually reduced a lot more, because our target is, or our achievement is usually below 1%, but if the human is still sometimes 2 or even 40% just now. Okay, the third point is that we observe the the impact from the application is that we see the improvements of overall at least 50% in overall. And if the AI is possible to cover most of the defect from the most of the data buyoff from the post inspection, like I mentioned, it's possible to replace human being in the near or even maybe near future. AI technology has been very essential in supporting inspection system in achieving auto data judgment, moving towards operator reduction. But I want to highlight that in fact, it's not only about operator reduction, but it's also on the overall process efficiency, including the throughput, quality, and of course, the cost in terms of the cost, right? Okay, I have already gone to the last page of my slides where I'm talking about the future plans. So definitely our aim is continue to work on the AI accuracy improvement to achieve higher target of accuracy and reliability. Then we want to be able to enable the auto judgment by AI for all the equipments with a strategic deployment plan. And for information, currently the AI deployment is available on the AOI and also the AXI systems for ViTrox. So in future, we hope to have more clients that are interested in this, and we're definitely more than happy to be involved in working together to achieve this the success of this whole project. I think I've ended my presentation, and this is my my email address. So I'll pass back to you, Haley. Thank you very much.
Thank you, PG. It's a very interesting and good work, and also the case study shows the improvement that AI may bring. So now let's open the floor for questions. I didn't see any in the chat. If you have questions, you can unmute yourself.
I will unshare my screen just in case I want to see the chat box.
Sure.
The questions. Yeah, thank you.
Hi, Haley and PG. This is Wayne. I want to ask a question. Very nice sharing and very good work here. I appreciate that. So PG, I want to ask in the sharing of your data, right? And For example, if you are going to train a AI model for a certain classification, I know you have a special recipe there, right? You have different layers and that kind of work. But typically speaking, for one specific AI model, how many image data do you need for a certain types of defects, for example, right?
I would say that now our AI modeling has come to a stage that it's already available for all the different type of defects. So once we install and deploy, it is usually good to go. But of course, if there is something that is like a new pattern that is not trained previously, so we will have to collect some images. But in fact, we don't need a huge amount of information or data already. In fact, 1 or 2 is the minimum numbers that we will require.
Okay. And yeah, thanks for the answer. And also in some of the defect image you share, I noticed that you also cover in terms of the coverage, right? You in your solution you also cover those types of like the leaded IC, right, component. And but typically you know in the board design, the IC component would be typically in terms of the amount and quantity would be less than those chips, right? That's our understanding. And so that means in your data groups you may have certain imbalanced data distribution, right? So some chips might be in a higher amount and those IC with leads will be in a lower amount, for example. So for this type of imbalanced data, how do you handle that? I mean, from a data scientist and from your best practice advice, yeah.
I would share that from the beginning of the development for this AI, we actually implemented the very classical way. So by that time, we actually collected a lot of data from the field already, and then we observed that it is not that efficient because we keep on training. So by that time, we actually already have a set of the fundamentals training that data that we have, right? Then we go for generic models. I'll say, meaning that let's say the models covers for missing component. So it will not care that whether it is a chip component or it is a BGA or SOIC. So any type of components, but it falls under the missing, will be able to cover. So I would say that the model will be generic for different type of components. So if the distribution is not in the like you said, right, the distribution pattern, I don't see. But of course, a certain condition like the data that I shared, sometimes you will see the percentage of this particular data is higher for AI coverage, but the other one is not. So it depends on the type of the defects that happen as well. And some with the very good yield, or some is very bad yield, and the data could be slightly different as well.
Okay. Yeah. Thanks for answer. Yeah.
Thank you for the questions.
I see a question in the chat from Bart. He asked, how do you achieve more AI accuracy? Is that by having more data or changing algorithms?
I would say we actually do both. Of course, let's say we observe the data is not accurate, we definitely will collect the data from the field. For instance, images and the data from the client, and then we will analyze accordingly. What is the issue with that particular problems? Is it due to the AI is overkilling because of the model is too strict to cover or to handle that particular condition, or because of the condition that the other factor, for instance, the algorithm set up in the AI is incorrect. So we'll do a observation or analysis to see what is the actual reason. And if required, we definitely will do the training accordingly if we need to handle that particular situation, because it's the issue is coming from the AI. Meaning that changing algorithm is possible in the AI modeling.
Thank you. Any other questions from audience? Okay, we have a question on how why is the cycle time improved?
If you're referring to the cycle time that I mentioned in my slide, in fact, that is the speed that the operator is doing the job comparing to the AI. So eventually, like I mentioned in the very early slides, operators need to hold the scope and manual verifying the defects if they found from the AOI. So that will require a longer time if comparing to the AI, because AI will do just probably within a few seconds. Then you can see all the data plotted in the VVTS in the repair station. So it does not require people to double verify. That is the cycle time improvement that we are referring to. So in the other terms, the processes that requires to do the verification is much faster. Okay.
Any other questions? Comments? In fact, in the morning session, there are people asking about the to integrate the AI model into the solution to the equipment, the process. I just wonder if you have any comments regarding the hardware requirements or this, if people are interested on implementing AI, do you have any suggestions to them?
Yeah, of course. For the AOI system or even the XI solutions that we integrated for our solutions, we will just require a very normal PC. But of course, we have certain minimum requirement on the graphic card specifically. And it is just require a normal PC to run the AI application. Does not need a very heavy duty server. The server will be required only for data mining at the later stage, where like the charting that I showed. So those will be running at the server side.
There is a question regarding the AI engine run locally on the tool. Is that?
Yes, correct. It is running locally. In fact, we only have to install it in the offline the repair station. We don't have to have it in other PCs. So it is a standalone application, but integrated into the repair station. It's a local, it runs locally, yes.
Okay. Any other opens or questions? Okay, if not, then I would thank PG for her sharing and the introduction. We will share the presentation material later, and also the webinar recording. I see another question in the chat. How do you deal with the process drift?
To be fair, I'm not really understanding what does that mean. Is that something to do with if the process becomes unstable? So data drift. Would you mind to unmute yourself just to make sure I understand your questions correctly, Jonathan?
This mic is not working.
Okay. I try to answer your questions based on your question. Based on what I understand, right? Okay, thank you, Bart. I saw your message and thank you very much for the questions. So, Jonathan, in terms of the changes in material, etc., so you mean that based on the real-time environment, there's data that change or the pattern change, right? Remember that I shared that we also utilize the template, one of the template. Maybe I can quickly share the slides. The template. So if there is a change of the models and we are able to get the template, yeah, this one. So if we are able to get the real-time template, the AI will be able to correspond immediately to the change, and therefore it handles the change to the correct template or to correct input that it receives.
Okay, any additional questions? Okay, I think we are approaching the hour. Thank you, PG, and thank you all for your questions and your input to the discussion. So if you are interested if you have further questions, you can contact me, or I think PG also shared her email contact as well. Okay, thank you all.